So we need to find the electric field right here at point P, right? Now these charges are both positive charges. Remember that electric field is away from positive charges. So this electric field here, the electric field due to A is going to be like this, kind of like that, right? So that's the electric field due to A. And the electric field due to B is going to be kind of like this, away from B. It's always sad to get that wrong, you know. And then if we draw a line like this, we better find these angles here, right? That's not 45 degrees. That's, what is this angle? I could draw this. We've got, this is the same angle, right? So this angle right there is tan minus 1. What is this? 1, 2, 3 over 1, 2. 3 halves. Tan minus 1 of 1.5, right? How sad is it if we get like one little bit of this thing wrong too? Okay, so let's just double check. 3 and 2. Okay, we're good. I'm getting all paranoid now. Okay, so that's 56 point, I'll say 31. That's this angle here, 56.31. All right, and then this angle right here, we could call it maybe theta 2, is the same as this angle, right? I'm using what, alternate interior? No, wait, that's opposite angles, right? So this angle right there and that angle right there are congruent. So this is the inverse tan of 1/3, right? It's a small angle, so I'm going to go second tan of 1 divided by 3. 18.43 degrees is this angle, okay? And this guy right here is 18.43 degrees. This is going to be fun. Okay, so let's see. So let's figure out EA, okay? The electric field at A. Or I'm sorry, the electric field at P due to A. That's what I'm trying to do, right? And this is KQ over R squared. This is not in your data packet, so do memorize this. Okay, so this is going to be 8.99. Don't know why it's not in the data packet either. Okay, A is 1.3 microcoulombs. Right, and then we are, it's R squared, right? So we are, is the square root of 1 squared plus 3 squared. Each square is a meter, right? 1, 2, 3, 1 meter. There we have it, right? And then, of course, that's squared. And, of course, the square and the square root they'll go away just like they always do. So I'm going to go alpha F1, and I've got 8.99 E9 times 1.3 E minus 6, and then over 1 squared plus 3 squared. I can't just put a 10 down there. I got to do this. All right, here we go. This is 1168.7. And that's newtons of force per coulomb of charge. Let me just double check. Yeah, that's good. All right, and then let's find the electric field due to B at P, right? This is just the magnitude, right? So it's the same thing, KQ over R squared. Okay, and then that's 8.99 E9 times, and let's see, B is 3.1. Dyslexics beware. E minus 6. Okay, so 1.3 and 3.1. Did we get it right? Yeah, we did. Okay, good. All right. Okay, and then we are 2 over and 3 up. So I'm going to go 2 squared plus 3 squared. Okay. I might be so lazy that I'm just editing the old thing I just did. Oh no. Okay, hold on, stay there. 3.1. All right, so now I've got 8.99 E9 times 3.1 E minus 6 over 2 squared plus 3 squared. It's 2143.77. I'll say 0.8 just for kicks, because we have so many sig figs. All right. And then this guy is EA is, this is to the right and down. And it's 18.43 degrees below the axis, below the x-axis. And this one is, so let's divide, let's keep it all separated. This one is up and right, and it is 56.31 degrees above the x-axis. I find it's very helpful to do this because I'm such a spaz. I'll often mix these, like this number with that number. It's like, oh, that's so sad. Because you do all this work, right? Okay. Okay, so now we need to carve up some little space here, right? So let's go EA, EB, and then we'll go EA plus EB. Okay, and then of course we're going to have to do the X direction and the Y direction. Okay, here we go. Whoosh. This kind of makes me happy to close off that thing over there. Okay, okay, so here is A. A is this guy, 18.43. So let's see, the X component is going to be 1168.7 cos of 18.43. Right, because this is the X component goes wingy, 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 like that. The Y component is going to go down, right? So this guy in the end is going to be positive. This Y component will be negative because we went down, right? This X component for this guy will be positive. The Y component will also be positive. Okay, so let's see. What is 68.7 cos of 18.43? I'm going to go up arrow and find, there it is, I got it. Right parenthesis. I always have to close the parentheses even though I know it's not necessary. Okay, so this is 1108.7, I'll say 73 newtons per coulomb in the X direction. And then I'm going to do the same thing, only I'm going to do sine of, so this is going to be 1168, this guy right here, 0.7. Sine of 18.43. So let's do that. Let's see. Boom, Betty, boom. Whee! Okay, sine. All right, 369.6. I'll say 58369.58 newtons per coulomb. That's in the Y direction. Okay, so B, let's go B here. Okay, that's 2143.8. So B is newtons per coulomb. Oh, sorry, why did I put the units there? Okay, and then let's see. That would be, the X would be cos 56.31. So let me find that number, 2143. There it is, boom. Cos, and then I got to go up and find that 56.31. Still looking for it. There it is, baby. Got it. Boom, boom. 1189.149. I'll say 0.15. And that's newtons per coulomb in the X direction. And then I'm going to take the same thing and just do the sine of it. Okay, hold on, there it is. So this is going to be 2143.8 sine of 56.31. Boom. 1783.72 newtons per coulomb in the Y direction. Okay, now we got to make some moral decisions here. Let's see, we got to add this and this and get this, right? Okay, so let's see if I can find this. 1108, where's 1108? Is it up there? There it is, got it. Then I'm going to add the 1189 guy. These are all so similar. I'm getting 2297 7.9 newtons per coulomb in the x direction. And then I've got to add this. Now it's a little controversial, right? This guy has a slight negative component, right? So I'm going to go 1783. Let's grab that guy. Minus. I can't remember whether I made it actually minus. No, I never did. Okay, so minus that guy. Patumba. And this is still positive. It's 14.15 newtons per coulomb in the y direction. All right, we are almost there. Okay, so this thing is over and up. So it's more over, okay? It's almost twice as much over. So let's draw a picture of this guy. Whoa, 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 whoa. Right, and then it's up. And then the vector is that thing there. We could find this angle, right? So this is 2297.9. All right, and these are just components of electric field, right? This is so abstract. All right, so the magnitude of this thing is going to be the square root of 2297.9 squared plus. All right, so I'm going to do that square root of that guy squared plus this guy squared. 2698. Ooh, 2698.156. Totally don't have that many. We have like 3 sig figs, right? Okay, so this should really be 2 G's. It'd be 2700 or something like that. I just wrote the sig figs because people want to know. That's the magnitude of it, right? And then that angle right there is tan minus 1 of 14.15. That's the opposite side, right? Here's the adjacent side. Over 2297.9. All right, so second tan of the 1414 guy, that guy, divided by the 2297 guy. Sorry, I refer to them as my people. 31.6. So that angle there. There it is. So when you get done, you're going to draw me a picture of this guy. You're going to draw the thing there. You're going to label that angle. You're going to label the magnitude. If you do that, it's all yippee skippy. Wow, look at all this work. This is serious stuff. You guys are like physicists or something like that.